when you're asked to prove something, just make sure it kind of makes sense to you first. Okay? Those details. And that'll depend on our choice of delta. Okay? Structure of the proof is the same. This is going to require some clever algebra. Let's take a look. Good plan. Start from where you want to end up. Who can tell me where we want to end up? No, we want to end up with f of x minus L less than epsilon. And we want to see, then we want to end up with that. So we can go backwards and write the proof. Right? Okay. Any suggestions? Okay, I'm listening. How about we get a common denominator? That's always nice. Right? Okay? Why is this nice? First of all, is this legal? 1 minus x cubed and x cubed minus 1? Yes, because it's an absolute value. Right, so it's okay. 3 minus 5 and 5 minus 3 are not equal, but their absolute values are. Okay. Alright. I know this makes sense, but I also know that you never have to be able to think that way in algebra. Alright? So, do your best to keep track of what's going on. The logic is not that hard. Why is x cubed minus 1 beautiful?
Because it's factorable.
It's factorable. One of its factors is x minus 1. That's lovely. Okay. So, so we know it's x minus 1 times something, but the way I work, I want to be able to separate that from whatever the rest is. Okay? I'm going to separate that from the rest. Because now this is less than, we want this to be less than epsilon. And I want to change this into the worst case scenario, right? I want to see the largest number this could be. You agree? Okay. Again, we have to make a choice. We have to make a choice. We have to have some idea of where x is in order to see how large this expression could be. Okay? How do you find out what the maximum value of a fraction is? How do you make this the biggest it could be? Very good. Make the denominator really as small as it could be, and make the numerator as large as it could be. That's the plan. You understand? Okay, I'd like you to take 10 minutes and figure out what's the worst case scenario for this. And then I will return with my lecture. Start from here. So delta less than 1 means you want x minus 1 to be less than 1, right? So that tells us that x is between x is between 0 and 2. Right? Does that make sense? That's a problem. That's a big problem. Why? Okay, let's see. Let's work on the denominator. Let's see. We wanted to make this as small as possible, right? And then this is large. Okay, let's work on this. It's smaller, looks easier. So if I cube everything, yeah, and then it's in the denominator, so what do I have to do? Take the reciprocal. So I have to switch, right? So 1/8 less or equal to 1 over x cubed less or equal to 1 over 0. So when I say, I mean, there are two ways to do it. Either say this can be as small as you want, or 1 over that could be as large as you want, right? In both cases, you have a problem. If I say I want this to be as small as I want, well, small is 0. 0 is a problem. 0 is in the denominator. Or if you say 1 over this has to be as large as I want, that's very large. How can we fix this? X is too far from 1. Very good. That's the problem. Delta is too far away from 1. We don't want it to get close to 0. If x gets close to 0, x is in the denominator, all hell breaks loose. Right? In order to control x, control delta. But I had to send you to this trap. Forgive me. But I want you to understand what could go wrong. Okay? When you encounter this in an exam, it's going to be bad. So understand that. Delta being less than 1, it's too far, it goes all the way to 0, we have a problem. But now, this is going to be okay. X minus 1 less than half. Add 1. X is between half and 3 halves. Where's x squared? X squared will be between a fourth and 9/4. Where's x cubed from here? It'll be between 1/8 and 27/8. You agree? Okay. So let's try to find a size for the top one. So, and everything's positive, right? Everything's more than 1/8. So we can just, without the absolute value. Where will, between what two numbers will this be? Well, it's not very hard to figure that out. X squared plus x will be between these two, added together. Basically add these two. X squared plus x plus 1. Okay? So this plus 1. 1/2 and 1/4 is 3/4 plus 1 is 7/4. And then this plus 1 will be this plus 1. This is 6/4 and 9/4 is 15/4 plus a 1 is 19/4. So the largest that numerator can be is 19/4. Okay? This is x cubed. And then we wanted to make this as small as possible, right? So the smallest this could be is 1/8. So here's the worst case scenario. X cubed being here, and the numerator being here. And so if I were to replace this with a number, I'd have to replace it by this over this. I'd have to replace, if I were to replace this by a number, I want to replace the top by the largest it could be, 19/4. And I want to replace the denominator by the smallest it could be, which is 1/8. Over 1/8 less than epsilon. absolute x minus 1 times, if you work this out, you get 38 over 4 less than epsilon. I'm sorry, 38 over, just 38. And so x minus 1 less than epsilon over 38. Okay? The rest of the proof is standard. Delta has to be the minimum of half and epsilon over 38. The rest is just doing all this backwards.